Today we're going to look at making voltage and current measurements for a parallel circuit. We've already done this for a series circuit. So let's see how we start. So I'm going to use a 7.5 ohm and a 15 ohm resistor. You'll have different resistors in your lab. So first of all, we're going to set up the power supply. Boom. And the other lead. Alright, we want to turn on our power supply, crank up the current all the way, and then you can see that this is at 12.5 volts. 12.5 volts is going to wipe out our current, or our circuit resistors. So we're going to dial this down to about 5 volts. There we go. So we're at a nice 5 volts. So let's set up the multimeter. So I'm going to set up the multimeter to read voltage. So I'm going to put this in here. Put that guy there. Common. Go to DC volts. Now let's check the voltage of the power supply. So to check the voltage coming out of this power supply, we can just touch these two leads. And we see that we have 5.06 volts. That's about what we want. Now that we're at 5 volts, we can plug this in. There. And plug that in there. As we saw in our earlier lab, the voltage is going to stay the same. All right, so if we want to read the voltage across this resistor, put those in there. And okay, I got 4.98. So I have a little bit of voltage drop in my system, but almost negligible. All right, so there's one circuit. Or I'm sorry, there's a circuit with one resistor. Now let's put this resistor in parallel with this resistor. All right. So if you remember when we did the light bulbs, all we did is we put a little jumper from one to the next, and then another one to return from here and go back. Okay. So now we have a parallel circuit. Get this out of our way, just like that. Now I can measure my voltages everywhere. So we might as well do that first. So let's measure the voltage there and there. 4.96 voltage here to here. 4.94. So pretty much the same. Close enough. Now that's the easy part of looking at a parallel circuit. We've looked at series, how the current's always the same. It's obvious here that in a parallel circuit, the voltage is always the same. Why is the voltage always the same? The voltage is always the same for each resistor because every single resistor has its own path to and from the power supply. The difficulty in this is in measuring the current. So in current, you remember we have to switch the multimeter over here to amps, move this guy over here. All right, so now we have the multimeter set up to measure current. So let's take a look at how we actually measure the current. To find the current coming out of the power supply, just take this piece out right here, the red one, then reconnect like this. There and there. Boink. So I have 0.9697 amps. All right, that's what's actually coming out of here. That's actually pretty close to this meter, but don't use these meters because these are usually just a rough estimate. They're not that accurate always. So we plug that back in. So that's my total current. All right. So now, to find the current on this guy, resistor 1, All right, we have to take something apart going into resistor 1. So what we want to do is we want to unplug this whole thing right there. Now this is what's going into resistor 1. So I'm going to go from here to there. This one gives me 0.65. All right, so that's the current going into resistor 1. Plug that back in. Now we want to find the total current going into resistor 2. So this is resistor 2. So let's take this apart right there. So this is the current that's going into resistor 2. There. And there. 0.31. And that's it. So we'll do a combination of 2 or 3 different So that's it. That's how we measure the current going into a parallel circuit. So to find the overall current, we unplug the lead going between the power supply and the first resistor and put the probe on both ends of that. To find the current going into this resistor, we unplug all of this and then reconnect here to here with the multimeter. And then to find the current going into the last resistor, we unplug this and put the multimeter from here to here. So that concludes today's lab. What you'll be doing is you'll be doing, I think, 3 different combinations of resistors to have 3 different parallel circuits. Once you've found your voltage and your current for each resistor, you should use Ohm's law, V equals IR, to actually find the resistance. All right, so when you do the calculation for this resistor, you should come out close to whatever its nominal value is. When you do the calculation for this resistor, you should come out with the value that's close to this one's nominal value. Now you won't be using 15 and 7.5s. You'll be using combinations of 10s, 5s, and 20s. All right, so these values were just as an example. So don't think that you have to get the exact same readings that I had on here. You'll have something different. So, as always, when we're done, we turn off our power supply. We turn off our multimeter. Get out the box that everything, all this stuff came in. All right. And clean up.